Today we're going to talk a little bit about mobile web performance. We're going to look at the cost of latency to really understand if you're not fast out there, what does that mean? What does that cost you? What does it cost companies in general? We're going to talk about the issues and the gotchas and what you can possibly do to help with the situation. So yeah, so that's yeah. So I've been here 2 years. I've been in the startup game a long time as well. So I have a tremendous amount of respect for what's happening here, and I think growing up, right out of college, I jumped into the startup scene, and two of the things I learned and that I've taken away is that your problem-solving skills go through the roof, and you learn that anything's possible. And what you find as you grow into big companies, you run into people who don't take that with them, and so there's a lot of conflict. Yeah. So, anyways, so mobile, right? It's a huge topic. I mean, we're not going to solve the latency problem here today. But what I'm going to do is talk to you about some things that are a little bit more under the hood as far as what causes slowness in mobile activity. But the topics are huge, like mobile hardware does not equal desktop hardware. Right? As much as they tell you, oh, this is good, quad core and 2 gigs of RAM, I mean, there's a lot of studies out there that refute that. And then there's mobile browsers, all the things, the evolution and how fast that technology is moving, things are changing very, very rapidly. And then there's the mobile network. What's happening with your phone when it talks to a cell tower, and what are the slowness elements that get added to that? And that's where I'm going to probably spend most of my time talking. I'm happy to dive into other things, but and then there's everything else. I mean, there's just so much out there. Google's got a whole team devoted to making the web faster. They're putting out their own protocols, and there's a whole generation right now of I guess developers, a community developing around performance optimization, figuring out how to make things really fast. And I think it's probably bigger in the Bay Area, but I'm hoping with Edgecast having a presence here, we can kind of help to make that blossom. So this is where we are today. Mobile performance, right? It's very immature. Like we probably today everyone's been focused on building the app for the end user, and all the little intricacies of dealing with Android SDKs and iOS SDKs, but really we're just scratching the surface of mobile performance. So the other thing too is today the web is not designed for mobile. So there's a huge difference between the web was designed today and what mobile is being used for. And so there's an explosion of content. Phones now can generate HD video, and largely it doesn't have a good place to go. You've got increasingly rich content, lots of dynamic pages, and you'll load a phone or a page on your phone, and it's doing all sorts of crazy JavaScript things. It's taking forever to load. You get really frustrated, and you're done. So, and then lots of animation, graphics, and acceleration. So 3D acceleration. So onto the cost. So what does it cost to be slow? So these are somewhat dated statements, but they're all factual. So Amazon says 100 milliseconds of latency costs them 1% in sales, and when you're making billions of dollars, that is a lot of money. Google says 500 milliseconds in search page generation latency drops your traffic by 20%. And then this group put out a report which they charge a god-awful amount. It's like $3,000, but basically, the gist of the report is that a broker could lose $4 million in revenue per millisecond if their trading platform is 5 milliseconds slower than the competition. So the cost of latency is very high, and optimizing around that from the start gives you the best chance of success moving forward so that you are able to capture and retain the eyeballs amongst the many distractions for those eyeballs. So.
What does it mean that Amazon loses 1% of their sales? Where does the customer go? Do they just come back later?
It could be frustration. It could be the fact that when they're at the cart and things were not as fast as they could have been, they decided that wasn't something that they wanted to purchase at the time. It's really driven around frustration of the user. And so these are all, I mean, there is obviously diminishing returns, right? If you have zero latency, you're not gonna capture everything. But yes. So speed will make or break you. So you know, a part of this is from Joshua Bixby. He's the CEO of a web performance company called Strangeloop. But he put out an article kind of stating, you know, the average channel size across browser types, and then the average bounce rate across those browsers. And so it's pretty clear, one, people on mobile browsers are spending less time on your site, and they're also abandoning faster. Okay? And so the question is why? Why is this happening? And I mean, he asserts that it's largely due to performance, but there are other factors, right? You know, it's a smaller screen. The experience on mobile sites are slightly different than what you would see on desktop, but just some anecdotal evidence. So, under the code, so less well-known offenders of mobile network latency. So again, you know, developing applications is a complex art. Lots of credit to the engineers, but we at Edgecast, we think a lot about the whole end-to-end kind of ecosystem. And so what I want to talk to you a little bit about is what happens when your phone makes a radio connection with a cell tower, and what's really going on there. And then what are cell providers doing from a routing standpoint? Like, where are they sending you when you send data out to the network? So typical network performance from a mobile standpoint. And if you look here, in the US, round trip times, and that's just the time it takes to ping something, right? Here in terms of the web. But typically on a desktop with Wi-Fi, you're seeing 50 millisecond round trip times, 5 megabit per second throughput in the US. But if you look at mobile network latency, it's significantly slower, almost an order of magnitude slower. And so it's not necessarily reflective of what you may hear in terms of, you know, you're getting, you know, 25 megabit per second throughput, but nobody talks about the round trip time latency because that's kind of all hidden under the rug. So. But yeah, so the promise is LTE. It's supposed to be faster. We haven't seen this yet. I think on a good day, my phone gets me like 10 megabits per second, and the latency is still up there. I mean, you're not going to get, you're not seeing 100 millisecond round trip times today. So, two things. Like when you hear the commercials from the providers, they talk bandwidth. And it's true, right? If you look at this graph that was put together by Patrick Meehan from Google, he's a part of the Making Web team faster. As page load times increase, or they decrease as bandwidth improves. And so 3G is really good punished. But for the most part, as LTE bandwidth's gotten better, once you establish a connection, you're getting data, and the pipe's big enough, you're competing pretty well against other methods of data transfer. But really, where you see an impact on digital times is latency. And so, really, you really get punished in terms of as you incrementally add 100 milliseconds of latency, the page load time is just and so I will dig into latency a little bit. So where does some of this latency come from? Why is it so slow? A lot of it today on the mobile landscape has to do with making a radio connection. So if you want to transmit or receive data on your mobile device, you've got to open up a radio channel with your cellular provider, the closest antenna, wherever it may be, right? That's slow. It generally takes several seconds, right? So, and when after you've waited several seconds and whatever you're looking for is loaded, if for whatever reason your activity goes idle, they basically cut you off at the knees and say, if you want to come back and get more data, you've got to do this all over again, right? And so you'll notice on your 4G phone, you're wondering, well, I thought it's supposed to be 25 megabits per second. Why is it taking so damn long, right? From page to page. I just read the first page of this article and I had to wait and look. This is not 25 megabits per second, it's the latency. That's the problem.
What are those connection statements on
Good question. So here's an example of how cell providers handle these radio channel resources, right? So if you look here, when you first open up a channel with a radio tower, you get a dedicated radio channel for the time that you're there. And you open up a channel and your antenna on your phone actually spikes the power usage on your phone so that you can go ahead and consume all the data that's coming into the channel. Once it's done receiving that data, if you go idle for 5 seconds, and that's, I mean, generally on a phone after you do a page of content, you're going to go idle. They throw you into what's called a shared radio channel pool, right? And so you're here, it's a much slower pace. They're expecting you to maybe get a little bit of data. If you start to suck down a lot more data, then they give you another dedicated channel and you're back to being fast again. And after another 12 seconds of idle time, you go into this idle pool, they cut you off, you're done, you gotta start all over again. And so the exact delays in idle timeouts depend on the carrier, which equipment you have, and the network. And so here's kind of a sample of carriers, and this is not like definitive data. This is all kind of sniffed out data based on some performance characters that we've seen. But all the arrows, what they mean is that they're just pointing to significant jumps in latency. And so you'll notice T-Mobile and AT&T really punish you, right? They're saying, you know what, after a couple seconds, your image load time just goes through the roof, right? And so the way they're managing their radio resources is much more aggressive than these other providers, right? And then you've got Sprint and Verizon, who are much more generous, right? They add about 6 seconds and they start to ramp you up, but not as aggressively as AT&T, right? And then you've got Vodafone, you know, who's primarily an EU provider, but they are by far probably the most generous with regard to their resource allocation, right? And so what does it all mean, right? Yeah, go for it.
What service do you have on your personal device?
I'm on Verizon.
Okay, just curious.
I was grandfathered in on the unlimited data plan, so I have ulterior motives for doing this. Hey,
So does this also apply to 4G? Does the same thing happen?
yeah, the radio resource control is applicable to 4G as well.
And it's on mobile phones as well as USB data cards and other
Yes,
devices?
that's correct. Yeah. All those that require a radio channel, that's how they handle the resource allocation. I mean, generally speaking, that was a simplified version of it. There's a few more pools that they manage around, but for the most part, it operates the same way. So.
And it's efficient from a carrier channel management standpoint?
It's I would not say that it is efficient. Over time, that model is probably followed as we learn. Yeah, and so I think that's one of the challenges they face. So.
Is that model used in Asia, Europe?
That is a good question. I believe so. Don't quote me on that because their technology is advancing far faster than we are. My understanding is that is the case, but I can't speak to it because it's moving so quickly. The data is in years, roughly 6 months. So what does it all mean, right? So connections requests on a mobile client are an extremely precious resource. So when you're trying to put a good foot forward and try to get your clients interested, or not clients, but end users interested in what you have to give them and what you have to show them, you've got to make your decisions and trade-offs about how you're going to do that, right? One of the things that's interesting is some application developers who figured out how the channel management works, what they'll do is they'll send a ping for a really small image, like a 1x1 GIF, and they'll keep that channel open. So they'll send it every couple seconds and kind of cheat the system. But what that does to the end user is it drains their battery, right? Because when you open up a channel, your battery utilization gets sucked up. And so they punish their end users, but they end up having really fast experiences with their application. Maybe you could take a different strategy and say, well, I'm not going to ping the tower every second. I'm going to ping it for the first, I don't know, five seconds because I know the user will probably move on from them. But again, if they're sucking up radio channel resources, to your point about resource allocation, that's going to affect you, that's going to affect me, it's going to affect everyone. So part of the engineering community that's developing these applications is a little bit of like kind of do right by other people leveraging this resource, not just yourself, but get your favorite application, it's okay. So, obviously, more connections aren't necessarily a good thing. If every time you have to open up a connection from your application, you have to pay some of these setup costs. Embedding resources today, like as a basic example, like if you look at a web page that has JavaScript or CSS, it's linked in as a different resource, and when you look at your browser loading, you see all these resources being called from the outside. Well, when you know that's a lot more expensive on the mobile side, maybe that's not a good idea to do it. Maybe you want to embed those resources into whatever you're calling down, if it's an HTML page, and you'll end up with much better user experience for that. And I mean, we see that firsthand. We do that a lot for some of our customers. And then caching is key, right? So the more, and this is probably bad for our business, but the more you can leverage the phone's cache to do a lot of the work for you, you're going to get better off. I think I read a study with regard to, like, is it faster to load from the local phone storage and keep JavaScript on, or is it faster to turn JavaScript off and just have it be really kind of non-dynamic and cache ruled out, like even with the most complex JavaScript. So it's bad for our business not to be able to deliver more cache to end users if you're using that cache locally, but it's really good for the users. And for those who are more technical, like embedded HTTP libraries on like SDKs, they're terrible because they don't seem to really caching support. So something to think about when you're going through and building your applications. So GGSNs, what is this, right? So the technical term, gateway, GPRS support nodes. Nobody really talks about this. What is it, right? But it's basically a gateway for your mobile network to get to the internet. That's all it is, right? And so it serves a couple other purposes. It can do packet filtering. It keeps track of your building numbers, but it also allows the law to phone caching, right? So And the way this works is they use a centralized strategy instead of a distributed strategy. And essentially what they do is they put these gateways in major metropolitan areas. For us, it's probably LA. So someone who's, say, in Nevada, right? They're probably a smaller market. And this was based on a study that was done through kind of sniffing out what some of these providers were doing. But basically, for a Nevada user, destined for a Las Vegas site, right? The site's probably a block from them, right? Well, the cell provider is sending the traffic to San Francisco, and then it's coming back to Las Vegas to get that content, right? And providers, they do this at will. Whatever, I mean, they make their own decision about how they want it about. And you can imagine that this strategy is not going to scale well for them over time, right? It's going to be terrible for them, it's going to be terrible for us. Well, unless you're right next to a GGSN, right? So, and here's another one with regard to latency for Sprint mobile users, accessing servers in Nevada and California. And the Nevada users actually get better performance going to sites hosted in California than they do in Nevada, right? And so the fact is that carriers will, they'll make their own decisions about where they're going to put these gateways, and end users will have to pay the cost depending on where they're located. So what does that mean, right? Get close to your users, right? CDNs integrate this. They have lots of servers and strategic locations. But seriously, like, use your CDNs better if you're using a CDN. I see it every day. Like I see a lot of misunderstanding about how to leverage our services effectively to benefit their end users. One of the things that punishes end users are redirects, and the fact is I don't think people realize you can actually cache redirects up front and use CDNs to do that, so that your users don't have to wait for that response to come all the way back to your web server and send all the way back to the end user, and then they have to go load another page on top of that, right? So it's punishing. Some other basic things are, make sure that you set cache control headers that says how long you should cache this stuff for, because then browsers will cache it and not have to come back and get it, and that'll save you money from a CDN standpoint, right? And then there's the issue of, well, my stuff can't be cached, it's too personalized, it's too dynamic. And what I say to that is that there's lots of ways that you can also leverage CDNs for that. Like, CDNs can cache personalization cookies, so they can say, well, this is the landing page for a logged in user, and it's probably good for, I don't know, a minute. Well, you can cache that, and you can also embed the cookies so it's unique to that user. The other things that Edgecast is thinking about that isn't really being done today in the computing landscape is building a stack of software that we can give to our end customers so that they can build on top of our stack and put little applications that will run all around the world in a distributed fashion. And they can still have their web server at home. But imagine if you had an application that was running, 20 milliseconds from the end user, right? The benefits there are significant in terms of user experience and just trying to push all that application logic out to the edge. And nobody's really doing that today from what I can tell. I look at our customers and how they're using our service. A lot of Amazon Web Services customers out there. But they're using like one location. They're saying, send all my traffic to New York or send all my traffic to California. And what I'm saying is maybe there's a better way to do this. Maybe you can build a small application that'll run on our servers in a distributed way and pay just a fraction of the cost of what it would cost to put out that infrastructure yourself. And maybe that would help accelerate the growth of mobile and its performance. And so that's where we're going. And I think that it would be be nice, like, out of this, to see if there's anybody who's interested in working with us, or partnering with us to explore this kind of technology. Because as it stands, I've talked to some other more larger established companies, and they've already invested in the way that they're doing things, and they don't want to divert from that because there's real dollars associated with the technology. But if we could really kind of get a foothold in the development community, places like this where they're open to thinking about how to design their applications in a way that are really different than the way they've been done today, it might give them a competitive edge in terms of helping to get whatever solution out and have users pick it up and use it and have it be performant. And yeah, so that's our team at Edgecast. Cash and Money Millionaires. That's our chief architect and a bunch of our developers. We have actually a pretty small technical group of guys that are building the software that is powering the Terabit network. And so, yeah, and if there's any questions,
So if I just open, I'm hanging with like Davis in LA, I do like 2 here in around good times. So that's, I'm assuming the channel's already open at that point. What channel open is? So what is causing that? Is that
well, what you guys have well, that's the thing, like, they don't disclose where they're located. And so what might introduce that additional latency, like, there are things that providers do, like, they will decide to cache something, or compress something that you didn't ask for compress, right? They will do that on your behalf because it's better for them. Because if they compress it, there's less data going over the pipes, and so why there may be additional latency, I guess, without knowing, digging deeper there, it very well could be where the GGSM is located. It could be just conflict of resources. Like, I don't know what's going on in the network right now. It's probably 6:30, people are getting on work, jumping on their phone. And so there's a lot that goes into that.
I guess I've been with the share channels, right? So it might be just on that.
It's quite possibly that.
As a web developer, if you have an existing website and you want to go and use this kind of CDN platform, what do you have to do on the website side? Is there a lot of working things you work at, or is it mostly on the hosting side?
In terms of general CDN use, if you want to take your website and use a CDN, it's pretty straightforward. You just add in a subdomain and call those resources from that subdomain. That's the bare basic minimum of working with CDN. What I'm proposing as far as a kind of a technology evolution for the CDN, that's going to require kind of a re-architecting of your site so that when a request comes in from your site, maybe it calls this little application that we let you run in Tokyo, right, for Tokyo user. Instead of calling all the way back to LA where your site's hosted, it's going to go to that local cache on disk and pull out all the relevant necessary information and construct the page right there and give it to the user, right? So that type of architecture is in contrast to what you've been used to, right? You've got a web server in LA, you get a request, it does the generation of the site and delivers it, right? You're not relying on a different service to generate that for you, right? But if you were to rely on that service for you, I mean, that would happen in 20 milliseconds, right? We'd call it right, we'd receive the request, go right to disk, call the information, construct the page, and send it out, right? Never have to call home to get that information.
How many of you guys are using just a standard CDN from caching at this point, running your apps? Anybody here? So if you're using Amazon Web Services, you can use Amazon Web Services CDN. It's called CloudFront. They'll charge you transactional pulls from EC2 or S3 pulled into Amazon's caching network. We have our own caching network that competes with the CloudFront piece. The difference is we're really just focused on the CDN itself rather than all the other Amazon Web Services pieces. So Hayes' team builds a specialized caching network, and all of the CDN piece, which is why you're hearing about next generation CDN stuff right here that we haven't built or deployed. But we'll have you guys loop in as soon as he's built it out.
We've built it. We just haven't talked about it.
We haven't deployed it yet.
Because I need folks like you know, to really work with me to help me figure out, what's the best way to use this set of technology for the evolving landscape of the mobile space, right? And those are some of the things I'm trying to figure out right now, because I know I have this set of tools and I know what we can do, and I have some use cases in mind, but I'd like to work with someone to help me figure that out. So we don't have it set in stone yet, but I think there's something here, and there's something here that nobody else is doing. So Amazon's not doing it, Rackspace isn't doing it, Google isn't doing it, and so I think if we can get ahead, it's pretty good for Edgecast, but I think there's also space for this in the cloud computing space.
And if you run out of funding, the names might hire you on this.
But yeah, so my whole point of this thing is that as you guys are going through and building whatever it is, next generation, whatever it is, chances are you're going to have to deal with the mobile users, right? Pretty sure. And as you're thinking about building good mobile user experiences, there's other things at play that are going to affect your end users. And it's just good to keep those things in mind from the beginning instead of finding them out later. And having, at the end of the day, where you find out your service, you get feedback, oh, our service was too slow, that's why we couldn't get users to stay on our side or use our service. Well, if you do that ahead of time, maybe that would give you an advantage when you're building it from the start. So that's why I'm talking about this. I mean, I would try not to get too deep, but try to give you guys a little bit of a picture of what else is going on under the hood. And then you guys will go and take that and dig into it and understand how to work the system, which is fantastic for us, easier for you, make it faster for us. So,
And what's your revenue model? How do you guys work?
Well, today we largely charge for direct CDN businesses. We largely charge on bandwidth and data transfer. What's your 95th percentile on bandwidth that you transfer, which is not unlike what transit providers or data center costs are like. But the model that I'm thinking for the compute model will be based on compute cycles. So eventually we'll let you build little applications on our infrastructure that will run in a distributed fashion, and maybe we'll say, well, how much compute capacity did you leverage in doing that application? If your application is lightweight, it's going to be pretty cheap because it's not going to take that much to run. But I definitely think we're moving in that direction. We're not there yet, but the hope is we get there soon. So. Cool.
Thank you.